Welcome to the Public Lecture Series. My name is Sam Wong, and I'm the chair of the Public Lectures Committee. And for those of you who have come to many of these events, you know that I'm about to ask you to set your phone to a setting that makes me not know that you have it. If you could please do that, that'd be great. All right. So we have a very, despite the fact that I'm a biologist, I'm playing mainly a functionary role here tonight, so I will just let you know that these lectures are broadcast on cable and also on webcast. And you can see them archived at lectures.princeton.edu. And we have a very busy season ahead of us. Next week we've got a panel on conservatism. We have the neurologist V.S. Ramachandran. Okay, so that doesn't meet my criterion. Okay, so we have V.S. Ramachandran. We have some very good writers. We have a lot of interesting things going on. And I think I announced last time that in the spring we have Andrew Sullivan coming and also John Waters. And so there's a lot of stuff happening. Now, tonight's lecture by Professor Carroll is in the Lewis Clark Vanuxam series. Mr. Vanuxam was in the class of 1879, and he was an insurance man, but he endowed this series in science. And speakers in this series have included Edwin Hubble, James Conant, Carl Sagan, Roger Penrose, Nancy Hopkins. Okay, I should stop now. Okay, all right. Okay. And Jared Diamond. And I will stop there. Tonight, Professor Carroll will be introduced by my colleague, Professor Leonid Krygliak from Genomics and Ecology and Evolutionary Biology. So.
Thank you all for coming. It's my great pleasure to introduce tonight's speaker, Dr. Sean Carroll. Dr. Carroll is professor of molecular biology and genetics and an investigator of the Howard Hughes Medical Institute. He's based at the University of Wisconsin in Madison. His research has centered on genes that control patterns of body plans and play major roles in the evolution of animal diversity. He is the author of the new book, Remarkable Creatures, Epic Adventures in the Search for the Origins of Species, which is the topic of his talk tonight. He's also written 2 previous books, which garnered a number of awards for popular science writing. Dr. Carroll is a member of the National Academy of Sciences, a fellow of the American Association for the Advancement of Science and the American Academy of Arts and Sciences. He has received the National Science Foundation Presidential Young Investigator Award, the Distinguished Service Award of the National Association of Biology Teachers, and numerous honorary lectureships. So we're really privileged to have him here with us tonight, taking time of his busy schedule to give us this lecture. Thank you.
In the mood for some adventures. Thanks, Leonid and Sam, for the kind introductions, and thanks for the invitation to come to Princeton. Thanks for all of you for coming out tonight. I know the Yankees are playing, and I'm happy to know that all the Yankee fans aren't here. That's a Red Sox fan talking. The search for the origin of species, both in general and of specific kinds of creatures, has entailed a series of truly epic adventures over the last 200 years. And I've had a wonderful time chronicling those in a new book. And what I want to do tonight is to share with you some of those adventures and to celebrate the explorers who undertook them. Now, I think author C.W. Sarum described adventure best as a mixture of spirit and deed. And I hope that you'll be inspired by their spirit and come away with a much greater appreciation for the magnitude of their deeds. Now, throughout this year, the world is celebrating the achievements of Charles Darwin, no doubt our greatest naturalist and a leader of a far-reaching scientific revolution. And my talk tonight is in part, my contribution to that party. But the making of the theory of evolution and its early growth and acceptance owe considerable debt to 2 other men, Alfred Wallace and Henry Walter Bates, who undertook even longer voyages and under yet more difficult circumstances than Darwin. These 3 men had a lot in common. They were all young Englishmen when they went off on their world adventures. Darwin was 22, Bates was 23, Wallace was 25. They were all extremely eager to escape gray, drab England or the glories of the tropics that they had read about from a few travelers. They were also prodigious collectors. In fact, I think they must have had some kind of OCD, some kind of obsessive collecting disorder, because they pretty much from their boyhood on, they collected and pickled and pinned and cataloged just about every critter that they found. But most importantly, as collectors, they developed an appreciation for the variety that each individual species exhibited. And from this really hard-earned knowledge, they evolved from collectors into scientists and asked not just what given creatures existed out in the world, but how those creatures came to be. And asked for the pursuit of that question led each of these men to unique discoveries. So what I want to do tonight is, in the first part of my talk, take a walk in the shoes of these pioneers to see how the theory of evolution by natural selection was born and first gained some traction. And to see how the creatures that they encountered led them to their respective insights. And I'll say that I think this period of these voyages and these three men's work, their discoveries, really formed the first golden age of evolutionary biology. And then in the second part of my talk, I want to explain why I believe we are presently in a second golden age of evolutionary science. Now, no one's adventures better fit that description of spirit and deed than Alfred Wallace. So my tales tonight are going to begin with Alfred Wallace in the Amazon. Now, Wallace had lots of motivation for going to the Amazon. The first was just to study its natural history. The second was to put together a collection. I mentioned that he was a collector, and he felt that he had pretty much exhausted what Britain had to offer. He also had the very practical motivation that he hated his day job and was looking to escape that as well. So he proposed to his friend and fellow collector, Henry Walter Bates, that they go to the Amazon to study its natural history, to build personal collections for themselves. But they had to come up with some scheme that would allow them to do this. And as they had no family wealth, they both ended formal schooling around age 13, the only way they could think of they would be able to afford to do this would be to gather extra specimens, duplicate specimens, and to sell them back in England to museums and collectors and things like that. And so they secured an agent and set up an arrangement where they would ship specimens back for sale, and the agent would forward funds to keep their collecting journeys going. Now, Wallace was also very well read in the science of the day. And one of the burning questions of the time was the question of the origin of species. This is the mid-1840s. And what he said to Henry Walter Bates, he said, quote, "Let's go to the Amazon and gather facts towards solving the problem of the origin of species." Now, what was that problem? The problem was, the question was, were species immutable, unchangeable, created by God in their present form and placed on the earth to live in some region for some appointed time? Or were they the products of natural processes, of natural laws? So Wallace said, let's go out into the wild, let's go out into nature and see whether or not we can gather facts towards solving this problem. So he and Bates made their way to the coast of Brazil in 1848, landing at Para. And after about a year of collecting, they split up to cover more territory, which is probably the gentleman's way of saying they got on each other's nerves. And we'll catch up with Henry Walter Bates a little bit later in the talk, but Wallace made his way up the main trunk of the Amazon, then up the Rio Negro, and then up one of its tributaries. And in the course of 4 years, by 1852, he was 2,000 miles upriver, further than any European had ever gone. And he had had it. It was, of course, an arduous journey. Travel was difficult and slow. There were hostile tribes, innumerable tropical diseases, poor nutrition. This was all taking a toll. And when he was finally laid up with yet another fever, 2,000 miles upriver, he decided he better turn around and head home, or he just might die in the jungle. He was also exhausted for another reason, because in addition to all the specimens that he was collecting for shipment back to England, he was keeping alive about 30 or so live animals that in cages that he hoped to take all the way back to the London Zoo. And just their care and feeding every day was just wiping him out. So he had this menagerie of animals, He had done all this collecting. He obviously had no more support system whatsoever 2,000 miles upriver. He had with him, for example, a woolly monkey, macaw, a toucan. So he gathers up these cages, decides it's time to head home. And he heads back downriver, 2,000 miles, all the way to Para. He finds a ship headed for England, kind of a lumbering ship, a brig called the Helen. Gets a berth on the Helen, loads up his specimens, including his animals, sets sail for England. Of course, he's starting to think, my goodness, I might have a warm bed and bread and butter and things like this. And, well, what happens next, I'll let Wallace tell you in his own hand. So about 4 weeks into the journey and about 700 miles east of Bermuda, the captain comes to his cabin and says, I'm afraid the ship's on fire. Come and see what you think of it. Now, Wallace is in a pretty weakened state still. He's just been recuperating from this 4-year journey and fevers and all this. So he's sort of in a haze. He just follows the cabin to the hold, and he looks, and sure enough, the hold is smoldering, and it could erupt into flames at any second. He realizes there's no time. He dashes back to his cabin. All he has time to do is to grab a small tin box, throw a few shirts in it, and put some of the drawings of Amazonian fishing. And so he has this tin box in one hand. He goes to the lifelines to go down to the lifeboats. He grabs onto the rope, and he slips and sears his hands on the rope, hits the salt water. I had to feel good on the rope burns. Paddles over to the lifeboat, climbs in, and realizes it's leaking. So he has to start bailing away immediately in the middle of the open Atlantic. This is 1852. And so from that perch, he can turn around and look and watch the Helen consumed by flames. And all of his collections which were in the hold, all the reward of his 4 years of privation and danger, burn and sink to the bottom of the Atlantic. There are some field biologists, I think, in this audience, and they feel this at the depth of their souls. Now, he couldn't dwell on his losses very long. He's in the middle of the Atlantic in an open lifeboat in 1852. Survival is in doubt. So his thoughts have to turn towards survival and rescue. And he says, day after day, we continued in the boats. We were scorched by the sun, my hands, nose, and ears being completely skinned, and drenched every day by the seas and spray. We were constantly wet and had no comfort at night. We had a short allowance of water, which left us constantly thirsty. The shipwreck was so famous that there was a book painted an artist's rendition of that about 30 years later. So there he was in the middle of the ocean, bobbing in this leaky lifeboat, day after day. And you have to think at some point, it might have occurred to him to think, how did I get in this predicament? And if he was going to blame anybody, if you remember that one of his reasons for going to the Amazon in the first place was to solve the question of the origin of species, if he was going to blame anybody, he might blame this guy, Charles Darwin. Because the irony of the situation was that Darwin already knew the answer to the question of the origin of species. He definitely knew. From a voyage he had taken 15 years earlier. He just hadn't told anybody. So, how did he know and how do we know he knew? Well, let me just spend a few minutes retracing, some of this is familiar, but retracing some of the steps of Darwin's voyage. Darwin, at age 22, left England shortly after Christmas in 1831. And one of the first important stops he made, or fruitful stops, I meant to mention, this is his narrative of that voyage, which we refer to today as the Voyage of the Beagle, is this book, which I'll come back to shortly. So this is how we know a lot about what happened on the voyage. But a ways into the voyage, made it to the coast of Argentina. Now, Darwin, in the later last year of his time at Cambridge, got a lot of field experience in geology. So he was eager to collect virtually anything. He's collecting rocks, he's collecting fossils, plants, animals, anything that he can find. He's not sure of the value of any of them, just crating them up and sending them back to England and hoping the experts will take a look at them. But on the coast of Argentina, in a place called Bahia Blanca, he unearths a whole bunch of fossils, including skulls and jaws and molars and vertebrae, crates them up, ships them back to England, and finds out many months later that the paleontologists are quite excited because some of these are species they've never seen before, and they all represent gigantic mammals, so-called megafauna of South America, sort of huge versions of armadillo-like and sloth-like and, say, llama-like creatures, such as this giant ground sloth that would just tower over me, that was named after Darwin, Mylodon. Now, this is pretty funny. These large animals, they're buried in the ground. They have some anatomical resemblance to the living mammals that are walking around South America, but they're clearly different. And this just plants a seed in young Darwin's mind. He might start musing about the geological relationship between the extinct and the living. Now, this was early in the voyage, but for Darwin, when he originally signed up, he thought this was going to be a 2-year voyage. That's what he was told. This is already well into the second year. And he figured out they're not going to be done in 2 years. And you may know that Darwin never overcame his seasickness. So to be on a boat this long was quite trying, and he wrote home, for example, I know not how I will endure it, as the voyage was going to continue. So how did he endure it? Well, he endured it because he didn't know what he was going to find around the next bay or his next inland excursion. We'd often go with horseback with various natives in to explore the inner regions of various parts of South America. And so he continued doing that month after month, eventually year after year. And finally, the Beagle made its way up the west coast of South America and turned west for the Galapagos Islands. Of course, we all know the story of the Galapagos. But the truth is, Darwin, according to his diary, he wasn't thinking about the creatures of the Galapagos. The geologist in him was excited. He wrote home and said, I'll get to see my first volcanoes. So when he arrives at the Galapagos, this is what he sees. He sees something he calls a reptilian paradise with big, lumbering, what he described as antediluvian animals and ocean-going lizards. You've heard of such a thing. The sailors refer to them as imps of darkness. And some humdrum-looking birds like this mockingbird. So yeah, a reptilian paradise, but not a naturalist paradise. It was hot as hell. In fact, it's literally what he said. This place reminds me of what the infernal regions must be like. And he was happy to leave after several weeks of collecting. It was uncomfortable on the Galapagos, and actually the variety of life was fairly scanty, and of course it was really hot. So he moved on. He had observed various things. He realized that, for example, the mockingbirds he had collected, they were slightly different forms that he had collected from different islands. And many months later, he started to recognize that significance. But he was all excited about continuing the voyage west because he would get to Tahiti, where he would see some of his first coral reefs, and then eventually Australia, and then Africa, and finishing the trip around the world, swing up the west coast of Africa, back home towards England. Except for his captain was Captain Fitzroy, who was more obsessive than any other person probably on the planet at the time. And Fitzroy decided he wanted to go back, and after all those years in South America, recheck some measurements. So instead of heading up towards England, they crossed the Atlantic one more time, back to South America. Darwin wrote home and said, I abhor the sea and all ships which sail on it. But he stuck it out. And he decided he had to make do with the time that he had on the ship. What was he going to do other than just sit there and feel nauseous? That he was going to try to be productive. And his plan was, remember he's now 26, 27 years old, his plan was that of all these specimens that he collected, he'd taken a lot of rough field notes, and he was turning both the specimens and those notes over to professional scientists of expertise in various areas, and was expecting them to do the formal scientific descriptions. And he realized his rough notes were not good enough for that. So he started to organize his rough notes into more carefully drawn notes as he worked through various collections. And he was working on his bird notebook on the way home, his ornithology notebook, when the light bulb was gone. So here's a page from that notebook. And what he's thinking about is he's thinking about the birds of the Galapagos, in particular the mockingbirds. And he says, when I see these islands in sight of each other and possessed of but a scanty stock of animals, tempted by these birds, the slightly differing in nature, in structure, and filling the same place in nature, I must suspect they are only varieties. And here's the key. If there is the slightest foundation for these remarks, the zoology of archipelagos will be well worth examining, for such facts would undermine the stability of species. Species change. So this thought enters his head and grips him. And once he's home in England, he enters a phase he refers to as his mental rioting, where he keeps a series of notebooks in his pocket and just fills them, stream of consciousness style, with all of his musings over the natural history that he had seen, posing questions, trying to answer them, often rambling jottings about what this might all mean. So let me share a few pages from those, a few quotes from those notebooks. And in one notebook that he's writing in 1837, he thinks back about Megatherium, an extinct sloth, and armadillos and other sloths. These must all be offsprings of yet some still older type. He's starting to think about the succession of animals over time. And he says, I think that organized beings, they represent a tree that is irregularly branched. Some branches are far more branched, as many terminal buds dying, going extinct, as new ones generated. And he noticed that there's a similarity of animals in one country, and that must be owing to their springing from one branch. As he went to Australia and to Africa, he didn't see sloths there. He only saw sloths in South America, where he also saw fossil sloths. So he's thinking he's only seeing similar animals in the same region. That must be to their springing from one branch. And then on the very next page of this notebook, a diagram that I think would be familiar to most of you, the most famous diagram perhaps in natural history, because it's an entirely new system of natural history. A system where life is organized as a tree, and where species are the product of previous species in just as natural a process as children are the offspring of their parents and their parents of their grandparents, etc. This was the end of special creation for Darwin. This was the end of the idea that species were created all at once by some non-natural process. But he didn't dare tell anybody. This flew in the face of everything that he had been taught at Cambridge. It flew in the face of everything that was believed by the scientific experts that were both helping him right now with his beagle collections and elevating him in the scientific world. Darwin was being heaped with praise for his collections, and he was rising very quickly, getting lots and lots of kudos for his efforts on the beagle. So he keeps this to himself, and he keeps this mental writing process going, and in the very next year he comes up with the idea of natural selection. Doesn't share that with anybody. And after a couple of years of this phase, you can sense in his writing, in his notes, a certain amount of frustration building, because Darwin was really a product of the new geology. He had gone off on the beagle and learned sort of a new view of the world that had especially been forwarded by Charles Lyell. And of course, previous to the geologists, astronomers had told us that no, that the Earth is not the center of the universe and things like this. So Darwin's thinking, why is it that we can take what the astronomer says or what the geologist says, but when it comes to life, that's somehow outside the bounds of natural law? So here's a quote from a notebook right about the time he actually came up with the idea of natural selection. And I'm just going to show you the text, a little transcript from above this. And he says, "We can allow satellites, planets, suns, universes, nay, whole systems of universes to be governed by laws. But the smallest insect we wish to be created at once by special act." And here's a guy who's collected a lot of small insects. And he's thinking, I don't see why some great power would bother with every tiny little beetle that I've collected in my life. So why is it, if planets can be governed this way, if universes can be governed by laws, why would the smallest insect be created by special act? Now, of course, he's still not telling anybody. But he had a golden opportunity to spill the beans. Because at the same time that he's having all of these private thoughts, he's writing up his account of the voyage of the Beagle for publication. This book, at least in its original form, if you ever see a copy like this, in a secondhand store, you do want to grab it. It's about $100 grand. So eventually, as he's described all the places he's visited and all the things that he's seen and all the people that he's seen, he's going to have to deal with the Galapagos Islands. Now, he knows species change. What's he going to say? he's going to dodge it. It is clear that the several islands have each their peculiar species of the same genera. When these are placed together, they will have a wide range of character. Think of all those finches with all their little different beaks. But there's not space in this work to enter on this curious subject. He dodged it. It was, of course, heresy. He was dealing with heresy. He later said, of course, to a confidant that admitting that species changed was like confessing a murder. He continued to work on his species theory. In 1842, he sat down and he wrote out a 35-page sketch in pencil of his idea. Still have the manuscript. And 2 years later, expanded that into a 230-page essay with a table of contents. And some of the headers in that table of contents are hauntingly familiar with respect to a famous book that's not going to appear for a long time. And we still have that manuscript. Now, when he finished that 230-page manuscript, he left instructions to his wife, Emma, to try to see that it be published if he should die. So he was happy to see it published if he was dead, but not while he was alive at the time. But the important point is that Wallace was privy to none of this. When Wallace later read these words in the 1840s, as he was planning his voyage and his ambitions, he concluded that the great Darwin had left the question of the origin of species wide open for he and Bates to come along and try to solve. Had Darwin disclosed what he had thought in 1839 or 1842 or 1844, well, Wallace might not have been in that open boat in the middle of the Atlantic in 1852, and we might never have heard of Wallace. But there he was, bobbing in a boat. And of course, if he hadn't been rescued, we probably would never have heard of Wallace either. But he was rescued. 10 days and 10 nights passed when a vessel was seen, and by night we were on board her, much rejoiced to have escaped a death on the wide ocean whence none would have ever come to tell the tale. Now, where am I getting this text? I'm getting this text from one of the most remarkable, certainly, pieces of correspondence I've ever seen. It's a letter that Wallace wrote to a friend back in Brazil once he was on the rescue boat. And he told his whole ordeal of how he left the jungle, made his way downriver, found a boat, etc., the boat catching fire, all the animals perishing, his days in the open boat. And he wrote this in sections as the days unfolded and still the long journey home from where he was rescued all the way to England. So he goes on a little bit further, and I think these are watermarks. You know, you're right on board ship, you get sprayed. Anyway, this is in the Natural History Museum in London. So fortunately, his friend who received this kept it. He goes on a little bit later in the letter, after explaining his whole ordeal. He says, you know, 50 times since I left Para, the coast of Brazil, have I vowed if I once reached England, never to trust myself on the ocean again. And who could blame him? But in another section of the letter, written a couple days later, he confesses to his friend, but good resolutions soon fade. So despite his loss, despite his near-death experience, he had nothing to show for the foreign lands, as he described, that he had trod, for the great things that he had seen. And the question of the origin of species was, to his knowledge, still wide open. So as soon as he could regain his health and get his affairs in order, off he would go again. Spirit and deed squared. And of course, it's going to be Wallace that's going to flush Darwin out into the open. So the question Wallace faced, 1852, 1853, was where to go. And he thinks, okay, now he's got the same deal. He's going to have to collect to make a living, but he wants to make a great collection. And he thinks, well, I'm not going to go to the Amazon. Bates already has that covered. So first of all, Bates is still in the Amazon as though one person could cover the entire Amazon. But anyway, I guess he decided not to press his luck twice. And he thought, where else in the world might I go? And he had read accounts of some travelers of the jungles of the Malay archipelago of Indonesia. And he thought that might be good grounds for collecting. So he heads off. And in 1854, he lands in Singapore. And he's going to trust himself to the ocean because in the course of the next 8 years, he's going to island hop from west to east across this entire archipelago. He's going to make 96 crossings totaling 14,000 miles. He's going to collect 120,000 specimens that this time will be secure. So once he arrives in Singapore, as I said, he's got to collect for a living. Off he goes in search of treasure. So what's he looking for? He's looking for things like this. giant bird-winged butterflies, named for their giant wingspan, but treasured, of course, for their magnificent color markings. Now, finding treasures is, of course, a sensible thing for a paid collector, but Wallace is paying attention to where he finds these things. And he's noticing that these bird-winged butterflies, and these are from Wallace's personal collection, it's in London, they were entirely different from the butterflies that he saw in the Amazon. And he also noticed that he found different species on different islands. And so these butterflies signal to Wallace exactly what the birds of the Galapagos signal to Darwin. Slightly different species on different islands. Only Wallace has none of the inhibitions that have been constraining Darwin now for more than 15 years. He's thousands of miles away from the center of science. He's an outsider. He has no reputation to protect and only a reputation to make. So every time he thinks of one of these observations, he's sending off articles for natural history magazines and for scientific journals. And right in that first year, he writes a paper. Look at the title of this paper. On the law which has regulated the introduction of new species. Fairly direct, I would say. This is 1855. The years will become important if you can keep track of them here. 1855, and he refers to this is known as the Sarawak Law paper because his ideas here were conceived on the island of Sarawak. What does he say in this paper? It's a fascinating paper, and I only read it really fairly recently, and I was stunned. He says the most closely allied species are found in geographical proximity. Birdwings are found near other birdwings. He doesn't see Amazonian kind of butterflies over the Malay Archipelago, and vice versa. So I think that every species has come into existence coincident both in space and time with a pre-existing, closely allied species. And you might like this one. The best mode of representing the natural arrangement of species? A branching tree. So he sends this paper full of observations. It's published in England. What does he hear back from England? Wallace, quit your theorizing. Send us some more of those butterflies. They pay no attention whatsoever. And he just keeps right on moving. Now, you got to remember, these lands are not well known to Westerners, so he needs always a lot of help from the locals in getting around, both transportation and in finding various treasure. And so, for example, the Dayaks of Borneo help him out. Now, this is a tribe that had a fierce reputation. They also had kind of their own natural history hobby of collecting. Kind of the right instinct, I suppose. But obviously, if this is one of these was Wallace's head, we never would have known who he was. But he made his way, and as he was island hopping west to east, some observations started to creep over him, and particularly when he made a crossing across a pretty narrow strait between the islands of Bali and Lombok. He noticed as he went farther east that whereas the western islands had things like, say, for example, tigers on Sumatra, and rhinos on Java, and monkeys and orangutans on Borneo, as he went east in this chain, he saw things like tree kangaroos and cuscus, marsupials. Now, why would that be? He starts to puzzle aloud. Why would that be? The jungles look very much alike. These are very similar habitats, the Borneo jungle and the New Guinea jungle. Why would that be? He says, it's almost as if there's a line separating the western and eastern islands, with the animals to the west being more typical of Asia, and the islands to the east bearing animals more similar to those of Australia, such as the kangaroo. But this is sort of funny because, you know about kangaroos sort of hopping out in the open country of Australia. What are you doing finding them living in trees in New Guinea? He says, this doesn't at all fit explicitly, he says, the creationist model. The creationists would say, if you're going to put animals in a jungle, you put monkeys in jungles. You don't put kangaroos in the jungle and stick them up in the trees. There must be some other explanation for this distribution of animals. And he says, aha, it's my Sarawak law. Species come into existence with closely allied pre-existing species. And he deduces, and he's been reading a lot of geology. He says, I don't think these islands like the Aru Islands in New Guinea and Australia, I don't think these were ever, part of Asia. But what happened here is that these animals are all closely related, and they've adapted to the individual conditions on the different islands. and they're totally different from those in the West. And we actually still refer to this line today as the Wallace line, and recognize Wallace as having discovered a fundamental truth about the distribution of life on the planet, that there's some sense to it. Not the sense the creationists thought, but a sense Wallace thought. And this, for Wallace, was the end of creationism. It made no sense. It made no sense. He had more of a historical explanation for how species were distributed. Bird-winged butterflies in the Malay Archipelago, marsupials in New Guinea and Australia, tigers and rhinos in Asia, etc. Okay, so species did evolve. The next question for Wallace was how. So he keeps island hopping, makes his way further east, and on the island of Ternate in February of 1858, lying in a dilapidated hut, baking in a malarial fever, wrapped in a blanket, it occurs to him. And as the fever starts to clear, he writes this down. Remember, this is somebody who's now spent 8 years in the jungle, in 2 different parts of the world. And he says, the life of wild animals is a struggle for existence and to provide for their infant offspring. Perhaps all the variations, the little differences he sees between the individuals of a species, must have some definite effect, however slight, in the habits or capacities of the individuals. And a variety having a slightly increased powers must inevitably in time acquire a superiority in numbers. He writes this all down in a short period of time, and he calls it On the Tendency of Species to Depart Indefinitely from the Original Type. Not a marketing genius. Okay. And he thinks, well, am I on to something here? Is there really something to this? And he would like to publish this, and he's been publishing prolifically the last 3 years. So I want to send it to a naturalist, for vetting before it goes on to publication. So he sends it to a naturalist with whom he had struck up a correspondence the previous year. He sends it to Charles Darwin, who's in shock. Now, why is he shocked? Well, the reason why he's shocked, what I want you to appreciate, is we have draft manuscripts of what Darwin was working on at this time and before. And when you look at those draft manuscripts, there are some remarkable parallels between what these two men were thinking, completely independently of each other. So a year earlier, for example, at Darwin's house, he's working on the chapter of book on species, and he titles chapter 5, The Struggle for Existence, as bearing on natural selection. And a little later on, as he gets into the description of natural selection, he says, all nature is at war. The struggle very often falls on the egg and seed or on the seedling. Any variation, however infinitely slight, if it did promote during any part of life even the slightest degree the welfare of the being, such variation would tend to be preserved or selected. No way for either man to know what the other was thinking or writing. How do we explain this? Well, they had observed the same things. They had traveled the world. They had seen species restricted to individual islands. They perceived that nature was, in fact, a battlefield, not this harmonious picture in the paintings of the early 19th century, but in fact, full of waste, and famine, and death. They had both read the social economist Thomas Malthus, who explained that the checks on human populations were those very forces: war, famine, death, disease. And Wallace had concluded, yeah, but those forces must be even 10 or 100-fold stronger in nature. Great minds think alike. They had really essentially computed the same pattern of observations and come out with even similar language. Okay, so the story is, Darwin thinks, Wallace is onto something. And he passes it on, as Wallace had asked, for publication. And 2 of Darwin's friends and confidants, who knew that Darwin had been working on this idea for 16 years at least, decided the best thing to do would be to publish Wallace's paper with a brief abstract from Darwin. Now, you understand this arrangement? Darwin essentially left this arrangement in the hands of his friends. He was completely distracted because at this very time, scarlet fever had struck the village, and Charles Jr. Was seriously ill and would in fact die that month. And Wallace was thousands of miles away, and they decided there was really no time to send a letter to Wallace to ask if that was okay and get a response back from Wallace. So just July 1st, these papers were read at the Linnaean Society, back to back. Darwin wasn't there. That's the very day that he buried Charles Jr. in the family graveyard. Wallace was thousands of miles away. So this is it. This is the public debut of the idea of natural selection. And nobody paid any attention whatsoever. Not a ripple. So much for the power of the publication process. So, in fact, the head of the society in a sort of an annual report at the end of the year had noted rather famously now that nothing of great import had happened that year in the area of natural history. Now, of course, Darwin had a slightly greater inspiration now to finish his great book. And the next year, 1859, November 24, this book appears, which, of course, everybody knows. And this is what we're celebrating this year. Its publication, in fact, 150th anniversary next month. So people paid attention. Why did they pay attention? Well, it's a great synthesis. It's written in a way that was accessible to the layperson. It marshaled all kinds of evidence, analyzed it from really both sides, pro and con towards his theories. It's argued clearly, persuasively, I would say very often phrased eloquently. And it heralded the end of creationism and a bold new view of nature. And it really set the agenda for biology and evolutionary biology for the next 150 years, and I hope beyond. And one of the immediate questions was whether this new idea, natural selection, could it really explain, is it really strong and sensitive enough to shape the fine differences among species? And fortunately, right at this very time, in 1859, our old friend, Henry Walter Bates, dragged his sorry, emaciated, exhausted self. I'm at an Ivy League school. Back to England. What had Bates accomplished? He had spent the last 10 years collecting the Amazon on his own, 11 years in total. He collected not 14,000 specimens, 14,700 species, 8,000 of which were new to science. He had suffered every possible deprivation and indignity, and many that he would not describe to his closest friends. Robbed, left shoeless, penniless, naked, every type of disease, chased by hostile tribes, etc. But to get some sense of this great spirit that motivated this man, in his later memoir of this time, he writes that the saddest day he can recollect is the day that the ship taking him home left sight of the Brazilian shore, of that land he described as a place of perpetual summer, and when visions of cold, gray, drab England started to re-enter his mind. So Bates arrived in the summer of 1859, and he was sort of starting to organize his specimens when Darwin's great book appeared. And Bates reads it. It gives him a framework for everything he'd seen in the jungle. And he realizes he has some gems for the great Darwin. So he strikes up a correspondence. He writes Darwin, he says, "I think I have got a glimpse into the laboratory where nature manufactures her new species." Now Darwin's taking a pounding from the popular press, obviously the church, etc. This is music to his ears. A naturalist with 11 years' experience in the jungle saying, "I've seen some things that you want to know about." So he says, "Bates, tell me more, tell me more." Now Bates has no scientific position. Remember, he went off as an amateur, never, no formal education, etc. There's no position waiting for him in England. In fact, for the first 3 years back in England, he lives with his family in Leicester. But Darwin roots him on. And what he starts to tell Darwin about was all sorts of observations where he noticed that in a certain vicinity there would be a completely harmless creature that resembled a noxious one, a poisonous, nasty beast. Such as, for example, this beetle, which resembled a wasp. It's not found in the same vicinity. Or better yet, this caterpillar that puffed up one end so it looked like the head of a small pit viper. So much so that Bates described that when he took this into the village, it scared everyone and they ran off. He thought, what would make creatures, harmless creatures, look like poisonous, dangerous, noxious creatures? Now, Darwin rooted him on. He encouraged him to publish his work and to write a narrative of his travels. But of all the creatures Bates encountered, nothing meant more to him than the butterflies of the Amazon. And he met a lot of butterflies. In one area alone, Bates cataloged 550 species, more than double the number of butterflies in all of Europe. And these butterflies gave him a special insight. What Bates noticed, if you looked at the first glance at these butterflies, you'd figure these two butterflies would be closely related and these two butterflies would be closely related, but you'd be wrong. It's these two butterflies that are closely related. They belong to the same family, which is a different family from which these two butterflies belong to. And what Bates realized, what was going on here? Well, he notices when he had specimens of these butterflies on his specimen table in the jungle, unlike other insects and butterflies, which would be taken away by birds and by lizards, they wouldn't attack these specimens. And he noticed that when these butterflies were flying through the jungle, they weren't pursued by birds. And when he handled them, he noticed that they emitted some foul, sticky, smelly, noxious substance. But not these guys. They belonged to the other family, but looked very much like them. And he realized that these other butterflies were gaining some advantage by mimicking, by resembling nasty butterflies that occupied the same area. And furthermore, he noticed that some butterflies were a pretty good mimic of the nasty species, and others were not. There was variability. And that made him think this must be the product of some natural process. It's not like these butterflies are stamped out like toys from a press. They're slightly different from each other. And so he concludes, he says, to exist at all in a given locality, our leptalis, that's these butterflies, she must wear a certain dress, and those of its varieties that do not come up to the mark are rigidly sacrificed. I believe the case offers the most beautiful proof of the theory of natural selection. Well, guess who else thought it offered the most beautiful proof of the theory of natural selection? Darwin, who wanted to tell Bates and the whole world so. Here's the actual letter that Darwin wrote to Bates. Language is right in here. I'll show you a transcript of it. Tells Bates, in my opinion, it is one of the most remarkable and admirable papers I ever read in my life. Darwin wrote a dispatch on it for a natural history magazine, writing that this is perhaps as close as we're going to get to the making of a new species on this planet. Seeing a butterfly changing to resemble a harmful species. And Batesian mimicry, which is a term we still use today, becomes an important new piece of evidence in support of Darwin's theory. How natural selection can shape such fine features of species that entirely unrelated animals can come to look alike. Now this is 1862, and finally in 1862, Wallace comes home from the Malay Archipelago. Now these three men, their science has become intertwined, but their lives are now going to be intertwined for the rest of their days. And there's very important relationships and connections here. In fact, very warm friendships. Darwin has now been in correspondence with Wallace for 5 years. He and Bates, of course, have been in constant contact about mimicry, and Darwin has been Bates' biggest fan and rooter. And of course, Wallace and Bates' friendship goes all the way back to their days in the 1840s when they collected in England and went on to the Amazon. And throughout each of their travels, Bates would write to Wallace when Wallace was in the Malay Archipelago, and Wallace would write back to Bates when Bates was in the Amazon. So for the rest of their lives, these three men promoted the theory of evolution, and they were lifelong friends. You mostly see them in this picture, but it's important to remember what they were like when they did this work, when they came to these discoveries, before they became icons. Now, the last thing I'd want to suggest, that this is really, I think, the golden age of evolutionary science, or a golden age of evolutionary science. But the last thing I want to suggest is that the great adventures were over. Far from it. There was much more to explore and be discovered, particularly in the fossil record. And for around $20, you can read about the next 150 years of those discoveries. How am I going to send a kid to Princeton? But moreover, I submit that we are in a new second golden age of evolutionary science. We are no longer restricted to just looking at remarkable creatures, but can see how they are made and how they've evolved. We're getting glimpses from the laboratory into how new species are made. And modern biologists, even the indoor biologists, are collectors too, and they're putting together menageries much like the one Wallace tried to bring home from the Amazon. And in these menageries, we have things like sloths and armadillos and platypus and wallabies and chimpanzees, only we're not taking them back to the London Zoo or stuffing them and putting them in the museum. We're taking their DNA and reconstructing from their DNA the DNA record of evolution and perceiving in that DNA how the fittest are made, how the different forms of various kinds of life have evolved. We've got, well, the numbers keeps growing every day, 52 mammals so far, more than 2,000 other species. And as we mine this massive record, we share that same sense of wonder and surprise and discovery as the pioneers. You know, only we don't have to barf our way to work in the morning, as Darwin did, or cope with malaria, you know, or headhunters. Just peer review. Talk about cannibals, hey, David? So, and we no longer stare at creatures like this butterfly, as Bates did, just dazzled by its external beauty, for we can now see the genes in action that are responsible for producing these beautiful patterns. We can see into the making of these creatures. And what could be better than fossils, such as the ones that Darwin collected? Well, how about DNA from these very fossils? New ways of peering into the past that, you know, not only Darwin could not think of, but few modern biologists would have thought possible until very recently. But those tales are for another day. My task tonight was to highlight where this all started. And among the past adventurers, the one we celebrate this year and above all is Darwin. Now, why? Well, I'm going to give Wallace the last word on that. And it comes from, I think, a very poignant letter that he wrote, whose circumstances are very important. There's been much speculation about how Wallace might have felt about that arrangement of the publication of his letter alongside Darwin's abstract of his idea of natural selection. Was Wallace robbed? Was there some advantage taken of him, etc.? Well, I think the best way to know how Wallace feels is to read it in his own hand, and particularly something that he wrote in private, in confidence, to a close friend at the time in question. So after the publication of The Origin of Species, Darwin immediately sent Wallace a copy in the Malay Archipelago, and we have that copy annotated in the margins in Wallace's hand with things like, yes, 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 exclamation point. He claims to have read it over and over and over once he received it. And on Christmas Eve, 1860, he writes a letter to his friend Henry Walter Bates. Another distinguishing feature is that Wallace had legible handwriting. And he discloses his feelings now, having read Darwin's book. He says, I know not how or to whom to express fully my admiration for Darwin's book, its overwhelming argument, and its admirable tone and spirit. Mr. Darwin has created a new science and a new philosophy, and I believe that never has such a complete illustration of a new branch of human knowledge been due to the labors and researches of a single man. For the historians in the audience, I submit this as the most gracious letter in the history of science. But this was echoed many times in other correspondence Wallace had. And Wallace, who lived for another 50 years, outlived Darwin by 30 years, was always deferential to Darwin. And of course, Darwin produced much more than The Origin of Species, the descent of man, the idea of sexual selection, all sorts of understanding of the domestication of animals and the biology of orchids, earthworms, the building of coral reefs, etc. Our greatest naturalists, and I think that's why we celebrate. So, for Darwin's birthday and for this anniversary of The Origin of Species, I want to close with a couple of wishes. And if Anna can cue that up, there we go. First, that more people will appreciate the great spirit that drove young Charles and Alfred and Henry and many other men and women to leave behind their loved ones and to risk their health and their safety, all just to follow their dreams to explore the unknown. And second, that many more people will eventually embrace the grandeur and the beauty of the story of life that they've revealed. We have time for questions, and I guess the mic is, I'll have to repeat the question as the way it goes, but if I'll answer the first question, that's you too. That's the soundtrack. And yes, we made that in the lab on a Mac laptop. Technology. questions, thoughts?
Do you think that Mr. Darwin could have written his book in 1838, or did he need those years to refine it?
That's a great question. Could he have written his book in 1838? I think a few years of writing. Having read the 1842 sketch, probably many scientists of the day would have at least published something about that level, a paper of observations and putting forward some ideas for everyone else to start to test. And by 1844, that was 230 pages. That was a lot of observation and thought that he had put into that. And some scholars would say, the next set of years was kind of, a lot of that was spent with barnacles. And, I'm not quite sure if barnacles really moved the theory forward that much. So I think within a few years of the voyage, I think he could have disclosed it. And of course, he might have been paid a very, very heavy price, except for the idea would have been out there for other naturalists to be, thinking about. And then, Wallace and Bates would have gone off to the Amazon with Darwin's ideas in mind, to make their own discoveries. Would history have been different? I don't know. But he knew a lot. He had really put together a lot within those first few years of the voyage. Way up the road. Students, I hear there's massive extra credit for asking.
I was appealed for the mimic of the butterfly. So my question is, what are your thoughts between what the animals do and what we humans do in changing us?
You mean in changing ourselves?
Mm-hmm.
So you understand the mimicry is nothing conscious on the part of these animals, right? That these animals are, the variation in these butterflies occurs at random. And the idea is that the birds are the art critic. And they're deciding, well, this one looks, edible, and this one looks like a nasty one. So there's nothing conscious there, right? The agent of selection is the bird, and the butterfly is merely the target. Now, I'm not quite sure what you mean by ourselves, changing ourselves. What did you mean by that?
For example, the idea of cosmetic surgery.
Oh, yeah.
That there is something.
Starting to contemplate that myself. So,
And also,
Yeah.
another is related of the dilemma of we can change how our offspring are, our children. So people decide taking
Yeah.
DNA for eyes.
Oh, you mean this?
All of that.
So, in terms of prenatal selection, this sort of thing. So, yeah. So, yes, we can change ourselves cosmetically. If it's in the post-reproductive years, it does not affect our number of offspring. If it's in the pre-reproductive years, then it might influence our breeding success. Depends what you do. Seems like whole body tattoos were a popular thing. And then in terms of selecting children, so yes, if we start to decide which offspring based on genetic makeup we have, then we're an agent of selection. Now, of course, that's just not happening on a scale that makes any dent in a population of 6 billion people, but we are in that position, yes.
Not yet.
Well, no, in some ways, certainly screening offspring. People could try to screen for certain traits that are sort of benign, but of course, people are screening for traits where the children would perhaps have some medical condition. We're there. Right? Yeah.
It's on.
Hi. So my question relates to the new Ardipithecus papers.
Yeah.
Basically, I was wondering if, from your perspective as a molecular biologist, how plausible it seems to you that humans and chimpanzees evolved suspensory upper limb characteristics from a non-suspensory common ancestor.
You mean?
Yeah, like wrist flexibility, range of motion in the shoulders, because the implications of this paper say that Ardipithecus couldn't suspend, and that therefore the human and chimp common ancestor couldn't suspend, but all extant apes and humans can hang from their hands.
So, well, I mean, I'm going to first say that I'm blown away by the work, and I think it's an enormous achievement. And then it now allows us to start asking these sorts of questions. I don't think as a molecular biologist I'm terribly qualified to weigh on this. The general question that comes up in evolution often is, are traits, when you see a distribution of traits and you look at groups that have or have not the trait, and you say, well, is it a possibility that this was invented multiple times or was inherited from a common ancestor? And what you're referring to is their inference that something was invented independently in two different groups rather than inherited from a common ancestor. And I think that, everyone, there's lots of people more qualified than I to weigh in on that. I simply don't know, the anatomical details, the biomechanical details to sort of weigh the plausibility of that scenario. Great question, but I kind of feel like Darwin in 1839. You feel that dodge? In this case, I don't really have an informed opinion. But I'm glad you brought up the papers. And I don't know if people here might have a different opinion, but I didn't know they were coming. I happened to be just sitting in front of the PBS NewsHour a few nights ago. I know Tim White, and I thought, it was one of those incredible moments of being in the scientific community where this massive amount of information and very provocative information is unloaded at once. And my kudos to the research team. And talk about great adventures. And maybe it's another. I'm just going to go off on another riff there, which is I've talked a lot about folks in previous era as though this spirit of adventure is over. The Ethiopian team and many other people, including people right here at Princeton, tell you that the spirit of these original adventurers is alive and well in biology today in droves. So thank you for allowing me to give that little bit in there. But 15 years of work in Ethiopia, I bowed because there were some hellish years in that place.
Hi. I was wondering what your take is on why do so many people still have a problem with evolution right now?
Okay, it's Wednesday night right now, right? I mean, the elephant in the living room is religious upbringing that puts it out of bounds for lots of people. I think this is the possibility of making some progress is undermined by the way the media handles the point. You'll see a young Earth creationist and evolutionary biologists, pitted for each other for 6 minutes on CNN to just do theater, right? That's not how we move forward, as a culture. And I know the media is biased in how they handle this because I have begged producers, both TV and radio, to get theologians and clergy, particularly clergy representing the many denominations who are completely comfortable with evolution, and they don't do it. There's plenty of prominent theologians, et cetera, that can explain this, and I think provide some leadership to their denominations to say, look, evolution and faith can coexist. It's a fact. Tens, 20s, scores of millions of Americans do that. We're kind of focused on probably the 30% that are absolutely opposed to any wisp of evolution. And of course, there's a few percent of people who will not accommodate, faith whatsoever, and you sort of see that being pitted against each other. And that's good theater for media, for the media, but that's not good ways for us to move forward. So I think as long as, and I find this everywhere I go, as long as a lot of kids, growing up wherever they do and whatever household they do, growing up with this impression that evolution is somehow, absolutely antithetical to religious faith, then if you have, I think actually if you had to choose between religious faith and scientific evidence, science is going to lose a lot. And that's going to upset some people. I'm just saying. I'm just talking about just analytically, just from facts of life. I'd rather have, I think it's, religion offers various things that science doesn't. And for a lot of people, those are very valuable things. And if they're raised to believe that evolution is a threat to that, it's no wonder that they're going to oppose it. So I think those are some of the dynamics, and I think the media has generally done a really, really lousy job of melting that divide.
I didn't mean to make you come over. I had a related question along the lines of Darwin's religion. So there's a current release movie that one can see in many countries other than the United States called Creation, I believe, that features young Darwin and focuses on a dramatic device, one in which his beloved daughter dies.
Right.
And this haunts him. I haven't seen this movie, but my understanding is that because I can't see it in this country.
Right.
My understanding is that the motif there is the idea that losing his favorite daughter cast doubts in his mind. And I guess I wonder,
Further
you've read a
doubts.
lot of these, right? Yeah.
Oh, yeah.
That
No doubt.
softened the ground for him to start questioning doctrine.
Yeah, he was already questioning because, he saw parasites that lived inside various bodies and thought, this is not too benevolent a creator in his mind. All the things that he saw in nature, all the waste, right? All, that far more offspring were made than could ever survive, et cetera. And then he saw this really working in his own family. So when his beloved daughter, who doted on him, he doted on her, and he died at age 9. This is 1851. It was, traumatic for Darwin and for the Darwin family, and furthered his doubt that the doctrine that he had been taught. He doubted that doctrine, and I think in all his writings, and he was, fairly hard to extract, unambiguous sentences out of. I think he felt that the current doctrine of Christianity, he described it as a damnable doctrine. How would you take a sweet child like that from the earth? Under what doctrine is that acceptable? And so that shook his faith further, and I think that he just drifted further and further away from what the norms were in the society he lived in. But I think it's, and other people here may chime in on this, I think it's still not clear how far he went away from believing, was there any creator ever in existence? I mean, he did say in some correspondence right near the end of his life that he thought that maybe we're going to discover that life is a product of entirely natural laws, the origin of life, and would not need necessarily a creator. But yeah, the death of his daughter was a big blow, and a big jump down the road towards, I would at least say, the loss of faith on Darwin's part. And as for the movie not being shown in this country, back to your question. I mean, I'm a movie buff. I'm into Zombieland. How harmful could it be to see a little movie with Jennifer Connelly and the actor who played the physician in Master and Commander? They play Emma and Charles Darwin. I mean, is this really going to hurt the country? Is that really the reason? No distributor would pick it up.
It is coming out. I'm sorry to interrupt you. In December it's going to be here.
So they finally, the distributor realized, controversy, get box office. So, I mean, my God, if Michael Moore can be a box office smash, can we just see a nice little British-made Darwin movie? Really? Is that asking too much? So, yeah, anyway, so thank you for that update, and, spend your box office dollars on creation.
First of all, thank you for coming.
Thanks,
And who would you say are the new pioneers of the second golden age? Who should we be looking out for?
It's a much, much bigger community than it was in 1859. And thousands of scientists are engaged in studying evolution at all sorts of levels. And it's a more interdisciplinary endeavor than ever before. And those subdisciplines have far more contact than ever before. Paleontologists and geneticists had nothing to talk about and virtually no interface even 15 years ago. And now, they write papers together. Most molecular biologists didn't know what the Cambrian was. Now they can use it in a sentence. And discovery is coming from this very more interdisciplinary area. And there's been, and I try to highlight, for example, that the genomics revolution has given us a record of species genealogies. It's given us a glimpse into the functional changes that have taken place at various steps in time, major innovations and things like that. So it's I don't think you have to look for a small number of heroes. If I had to write stories, now, there's a different thing. I'll spin this a little bit. The sort of flavor of stories. Look, this is the great thing when you get to write a book. I get to cherry pick the stories I wanted. Okay, what did I do? I wanted drama. I wanted important discoveries, and I wanted these to be admirable people. I said this in the preface. I want to write a book about miserable bastards. It's a great title, but and so there are folks out there that I think are doing work. Right? If I'm going to single out anybody, because I have to do this somewhat diplomatically, because I'm trying to tell you there's thousands of great scientists on this planet doing this. The effort we just talked about, Tim White's team in Ethiopia, Neil Shubin's discovery of Tiktaalik, this transitional tetrapod in the Arctic. There are folks out there, digging into the crust. Darwin said that the crust of the Earth is a vast museum. We've still just barely tapped that museum. There's more discoveries to come, and it's just they're harder to get to. They're in difficult places. It takes a lot of years. It's not, not so good for family life. But there are people doing this sort of thing. So if I had my little hero book, I just told you a couple. All right. Thank you. Peter Rosemary Grant. Sorry.
My question is it okay to interpret Darwin's law as a predictable, as something which predicts something into the future, or it only tells us about the past?
Well, I think it's predictable in the sense that this is an unending battle of, any organisms in contact. There's an interaction there. There's something predictable about that in terms of, this process of selection, this interaction, this battle between this battlefield of life. So, predator prey. The prey is evolving devices to escape the predator is evolving devices to keep up with the prey, things like that. I think that's only the sense of predictability that Darwin would have had, is that when you look at organisms, plants and all he really knew about were plants and animals, that there was a rationalization to what you could see going on in nature in terms of how organisms were interacting. So everything had a predator, and everything had parasites, everything had, mating systems and things like this. So I think his view of zoology was highly predictive. Ideas like sexual selection, it made predictions about what you would find for example, in the animal kingdom. But it doesn't predict, what creatures will be on the planet 10,000 years from now. That sort of thing. It's not predictive in that sense. If Darwin didn't know about them, he wouldn't have predicted dinosaurs, right? Who would? So, it's not predictive in that way. It doesn't know the direction of life. It just knows that this process is perpetual, this competition among organisms for what the available resources are there. I'm going to let you decide the questions. There we go. Sorry, there we go.
I'm curious about what your thoughts might be on the impact of medicine on evolution. I wonder if medicine, by keeping people alive who might have died of certain diseases, if we're actually weakening the human species.
Dodge that one. Now let's look at the facts. Yes, the selective pressures on us have shifted with civilization dramatically with things like hygiene, vaccination. Okay, so we are tinkering with sort of the large scale, with the evolution of our species in the sense that individuals who would have been susceptible to diphtheria, are protected, or go on and on with those sorts of examples. So anything that protects the young and the reproductively active matters, essentially in the big picture of human evolution. Are we weakening ourselves? Well, in the same time, unfortunately, this is one of those things where everybody in the room has an opinion. So mine's only worth like 3 cents. We are, look, 9% of Caucasian males are colorblind. That wouldn't work so well in the jungle in which we evolved. Okay, so you see in great apes, which have full trichromatic color vision, you see that they're very good at sorting out leaves and fruits and figuring out what they should eat and shouldn't eat, etc. some of us might not do so well seeing the lion coming at 30 yards. So many of us are living a lot more and having offspring that wouldn't normally have. But are we weakening ourselves overall by deploying knowledge and being able to harvest the talents of those people who lived, who would have died? I don't know. Net, I vote hygiene and vaccination.
In the middle of your talk, Darwin said something to the effect about the intense ferocity of the battle for survival. And it seems to me that that battle for survival was the playing field for the modifications that occurred. And I'm thinking about our present political life where we beat on each other, call each other names and so forth. And I'm wondering, is that essential for our evolution in the same way that it was essential for these insects and other creatures that are covered in that framework?
Not if it destroys everything alive, including ourselves. I think that would be a bad outcome. And dysfunction in that process, in the level where war, famine, destruction of natural resources, and crippling the ability of the next generation to be there. I think that would be the measure you'd want to use is, are we doing better each generation, or are we losing ground? I think what you can look at in terms of our evolution is that, ability of early hominids to make implements to either capture food or for shelter, and all of our ingenuity in protecting ourselves, and obviously fire and things like this, and even warfare. One could argue that, and of course our migrations. Our ancestral band that was probably 60,000, 70,000 years ago migrated out of Africa and populated 5 other continents. Those are very, from any view of zoology, those are very adaptable animals to be able to, live at all sorts of altitudes, to live at all sorts of latitudes, to live on various islands and things like this. So, our ancestors, modern human ancestors, were whatever process of competition among populations there, et cetera, whatever whatever fruit that bore, obviously that seemed to equip those people to be very resourceful, able to adapt to new lands, eventually, of course, agriculture, et cetera. So I'd say in that phase, with the way a biologist would measure success, we'd say, well, what about population numbers? And civilization allowed our population numbers to boom and us to occupy all sorts of space on the Earth. So if we were just looking at ourselves the way we look at a rat, we'd say we were doing really well biologically by inhabiting all this space and growing in numbers. Now, when there's 6 billion rats, and the rats have nuclear weapons, and the rats are polluting the oceans and covering all the land, we also know from biology where populations can crash, right? Where their success backfires and those populations plummet. So I'm not sure that our divisive political discourse is nurturing us as a species. It seems to be as great a risk as anything.
What would be required to happen scientifically so that the word theory wouldn't be used anymore?
Oh, the word theory, what would have to happen scientifically? Yeah, so you're referring to the fact that the use of the word theory of evolution sort of often undermines the popular connotation of what the theory of evolution means. I don't know. This is just a word that means a lot in science and means a lot less in popular usage. And if we taught the scientific method, or I would say reinforce the scientific method and the meaning of theory, from all relevant grades up, maybe we could change the connotation of it. I mean, it's just used as a debating device by those who oppose the theory to try to minimize it. Oh, it's just the theory, right? You've seen that used, uncountable times. It's also just right. So I don't know that the way to. I mean, I understand. A lot of us have this little reluctance in certain settings to use the word theory because of the population, because of the connotation. But I don't know that we can engineer around it to make sense. Maybe we should just try to teach what it actually means. But we're incredibly vulnerable to the trivial, rhetoric of just dismissing it as just a theory. Just a theory of gravity, but, try to fly to the moon without a rocket,
Or the theory of flight.
What's that?
Or the theory of flight.
The theory of flight. I think isn't there an onion? Somebody's going to have to help me here. What's the theory of intelligent gravity? Was there an onion cover? Somebody help me out with that, right?
Intelligent falling.
Intelligent falling, thank you. Couldn't grab that one, yes. Sometimes when scientists can't find the solution, the onion can. Yeah, there's also an article about dolphins evolve opposable thumbs. So one more thought, comment? Or
Yeah, one more, and then.
Is the mic right there?
Oh, sorry.
Is that a hand, or is the mic in somebody's hand?
Well, okay, let's go with Heather and then Taylor.
Okay, just shout it out.
I don't need a mic. I'm loud enough. I was wondering which side of the debate of what is the selectable unit of evolution you would fall on. So this is, of course, the most recent people being Richard Dawkins with the selfish gene and Stephen Jay Gould, who thought it was more of a population-driven selection. So I don't know, what would you personally say about it? What do you think, if Darwin had known about the selectable gene, where do you think he would have fallen?
He would have been inclusive, which is, I think, a good way to go. There's fruit in thinking across those domains of consideration. So, thinking about genes is a highly productive way forward in understanding the mechanisms of evolution, and thinking about the possibility of population-level selection and testing that is a perfectly reasonable idea. So, you probably noticed they're kind of a dodge, but it's a big tent. Evolution's a big tent, and there's plenty of room there for, there's also encompasses a whole lot of phenomena, and we don't want to be too narrow in our thinking.
Sean, this is not really a question, but just want to thank you for this lecture. And for people who are interested, who enjoyed this, should go to iTunes University and download the 7-8 lectures from the Cambridge series. Sean's lecture, The Making of the Fittest, is absolutely sterling. It's the best of the lot.
And we're not related.